Alright, ladies and gentlemen, so in this video we are diving into now synthetic division. Alright, so the goal of this video is to learn how and when to synthetically divide and really dive on into what does the remainder tell us when we're using synthetic division. Alright, so remember guys, specifically, alright, synthetic division can only be used when the divisor, the polynomial that you are dividing into a function, is of the form x minus k. Alright, x minus k. I apologize, that's not in there. X minus, I don't know where, oh, there it is. Looks like you just maybe got, there it is. Alright, x minus k. Okay, so a basic example we're going to use to start on off. First, we got to ask ourselves, check, are we dividing with x minus k? Yes, we have x plus 3, we're good to go, no problems there. Okay, it doesn't have to be negative either, that's kind of just a generic term that we use. Okay, so now, what is synthetic division all about? Synthetic division is all about the leading coefficients, alright? It's all about the coefficients in front of said terms that we are dealing with. So let's dive right on in. So what we want to look on into is specifically what is the k that we are dealing with. Well, because we are dividing by a form of x minus k, that means what that minus really shows is that it's just going to be the opposite of what you think k is in our divisor. So like in our example, x plus 3, k is not 3, ladies and gentlemen. K is negative 3, all right? Negative 3, because the negative made a positive, okay? So what we're going to do first and foremost is you want to put that k in its own little box on the outside of our division. So let's go ahead and do that. I like to go ahead and put k on the outside. Notice I'm not dealing with any x's at all in here. Then from there, what I want to highlight is each of the coefficients that we have in our particular example. So in this example, what am I dealing with? Well, I have a to the 4th power is 1. Whoops! I don't have a cubed function, so just like it was before, you have to have those little place markers in there. So now I will put my leading my coefficient in front of the cube as 0. Then I have a negative 10 by x squared, a negative 2 by the x, and then a 4 for the constant. So there is all my coefficients and my constants that I have. All right. So first and foremost, what's my goal? My number one thing is to find out what the coefficients are going to be for my end answer. By doing so, step number 1, move the first coefficient down. All right. Step number 2, multiply our k times that first coefficient. In this case, negative 3. All right. Now, next step, add our two terms or two coefficients of 0 and negative 3, which we get negative 3. Then, bring back once again, multiply negative 3 times negative 3 for 9. Then, repeat the process. Add the two terms. Negative 10 plus negative 9, or plus positive 9, is negative 1. Keep following the pattern. Now multiply negative 3 times negative 1, positive 3. Repeat the process. Add negative 2 plus 3, 1. Once again, repeat the process. Multiply on in here. Negative 3 times 1 gives us negative 3, and add 4 minus 3 gives us a positive 1. What does that tell us? Well, each one of these boxed off numbers is a coefficient of my new answer. All right? It's our leading coefficients. Well, think about it. I divided a degree of 4 by a degree of 1. What do you think the highest degree or the highest exponent is for our answer? Well, hopefully you see that it's going to end up being a cubic function when it's all said and done. So what this means is that I have 1x cubed, I have negative 3x squared, I have a negative 1x, and a positive 1 constant. But wait, there's a remainder. Well, that's fine. Remember the division algorithm. Division algorithm says that I can go ahead and throw that in there for my remainder. All right, guys, so that is a recap of synthetic division. Now, what does the remainder actually tell us when it comes to synthetic division? The process of synthetic division is usually simple, but it's why do we use it, when do we use it, and what does it tell us? Well, let's think here for a sec. What can the remainder show us when it's all said and done? Well, believe it or not, the remainder tells us a lot. The remainder allows us to find value of f. What do I mean by that? Well, let's think about it here for a sec. The remainder specifically gives the value of f at that specific value for k. So when x equals the divisor k, all right, or x, whatever the x minus k was, all right, it specifically gives us what the value of y is for x equals k. Super important, guys, okay? I can't tell you this enough, all right? The remainder r gives us the value of y when x does in fact equal k. What else does it tell us? Well, it also fills us in that, in fact, if the remainder equals 0, that means it divided in perfectly. And what does that mean? Well, if it divides in perfectly, that means it's a factor, right? That means it's a factor. So x minus k could be a factor of f, or is a factor of f, if r does in fact equal 0. And last but not least, what does the remainder kind of fill in for us in terms of some information? Well, once again, if we do not have a remainder, that means we just found out an x-intercept, and that k specifically is an x-intercept of the graph. And think about it, I mean, 2 and 3 really go hand in hand with each other because a factor means you have found a 0 solution x-intercept. All right, ladies and gentlemen. So let's take a look here real quick. What I want you to do as we wrap some things on up is to show that x minus 2 and x plus 3 are factors of the following polynomial function. Wow, you're going to do that. Ladies and gentlemen, think about what we just said. If, all right, there is no remainder, then x minus k is a factor. Ha! A little synthetic division, folks. All right, so use synthetic division to divide x minus 2 and x plus 3 into this function and show that the remainder does equal 0. Because if you show that the remainder equals 0, hey, you have shown that these are factors. Give this one a shot, guys. We're on to the next one.